What if we took an ordinary chicken egg and hurled it down from the edge of space? Would it fry in the atmosphere, shatter instantly, or somehow survive against all odds? And more importantly, what could this teach us about meteors, re-entry, and space travel? Before we crack into this, let's set the scene. In today's video, we're going to explore exactly what happens when something as fragile as an egg is dropped from space. We'll talk about the science of speed, heat, and impact. We'll see how physics treats delicate objects at extreme conditions. And trust me, the egg doesn't come out sunny side up. Welcome to Ifology, where we turn impossible what-ifs into mind-bending science adventures. If you're new here, hit that like button and subscribe. It helps us a lot and encourages us to keep making these insane, curiosity-driven videos. Alright, first, let's set some ground rules. We'll imagine our egg is dropped from the Kármán line, about 100 kilometers above Earth's surface, where space begins. And no, we're not cheating by putting it in a protective capsule or frying pan. It's just the egg. Raw, exposed, and at the mercy of space physics. As soon as you release the egg, it starts falling, but here's the weird part. In space, there's no air, so it doesn't really fall in the way you're thinking. It just floats, slowly accelerating toward Earth due to gravity. But give it time. Gravity's pull means that by the time it reaches the thicker layers of the atmosphere, it'll be screaming downward at thousands of kilometers per hour. Here's where things get scrambled. When it slams into the upper atmosphere, the egg doesn't just keep falling peacefully. It faces violent air resistance. This isn't like dropping it off your kitchen counter. This is hitting a wall of air at hypersonic speed. At this point, friction with the air molecules generates intense heat, just like it does with meteors. And here's the twist. The egg's outer layer will start to cook before it even breaks. Yes, congratulations. You've just invented the first space omelet. Now you might think the heat is the egg's biggest problem, but no. The real killer is deceleration stress. Imagine going from thousands of kilometers per hour to a much slower speed in just seconds. The pressure difference between the outside of the egg and the inside is so extreme that the shell will crack explosively. And even if somehow the shell holds, the inside will slosh violently from the G-forces, tearing it apart from within. But wait, what if we slowed the egg down before it hit the atmosphere? Could it survive? And what would happen if it somehow made it all the way to the ground intact? That's where things get really over easy. Let's say we cheat a little. Instead of letting the egg free fall like a tiny doomed meteor, we attach a small heat shield and a parachute. Now the egg re-enters the atmosphere slowly, like an astronaut returning home. This changes the game completely. The heat shield would protect it from burning, and the parachute would slow it enough to avoid explosive impact. In this scenario, the egg could land safely. But, and it's a big but, the G-forces and vibration during re-entry might still scramble the insides. So even if the shell survives, crack it open and you might find a weird, foamy, partially cooked yolk. What if we go back to the raw, unprotected drop? Well, brace yourself. When the egg finally reaches the ground, it will be traveling at terminal velocity, which for an egg-shaped object in air is about 160 kilometers per hour, 100 miles per hour. That's fast enough to make it explode on contact, splattering in a perfect circle of instant egg art. And yes, the shell will shatter into thousands of pieces. In fact, the shockwave from the impact is so fast that the yolk and white might separate mid-splat, creating a space egg pancake. Now you might be thinking, why are we talking about eggs when we could be talking about meteors? Well, the egg is actually a great analogy for what happens to fragile materials in space re-entry. Scientists use similar physics models to predict how spacecraft, satellites, and even space debris will behave when they fall toward Earth. The difference is, unlike an egg, spacecraft have reinforced shells, heat tiles, and controlled re-entry paths. Your omelet to be doesn't. Alright, here is a twist. What if the egg didn't land on solid ground, but in the ocean? Hitting water at terminal velocity isn't as soft as you think. At high speeds, water acts almost like concrete. The egg would still burst on impact. However, if it came in slowly with a parachute, there's a tiny chance it could survive and just bob around. You could, theoretically, scoop it up and make breakfast. Space to pan in under 24 hours. Here is the real fun of this question. It is not about eating a space egg. It is about understanding how extreme environments destroy delicate objects and how creative engineering can make the impossible survive. If we can't even drop an egg from space without destroying it, imagine what it takes to get humans, satellites, or Mars rovers safely down to a planet's surface. So what do you think? Could we design a container that would let a raw egg survive the journey from space to Earth? And if it landed safely, would you eat it? Tell us your weirdest, wildest ideas in the comments below. If you enjoyed cracking into this strange what if, make sure to like, subscribe, and ring the bell so you don't miss our next mind-bending science adventure. This is Ifology, where the impossible gets scrambled into science. See you next time.